Okay, we're going to find out if this series converges or diverges. We're going to use the limit comparison test. So with the limit comparison test, we have our original one, and then that goes over our substitution. We take the limit as n approaches infinity of this, and then we check, is this, whatever this is equal to, we want to make sure that it's not equal to 0 or infinity. As long as it's not equal to 0 or infinity, any other number, then whatever behavior b sub n exhibits in terms of convergence or divergence, a sub n will also exhibit in terms of convergence or divergence. So what are we going to let b sub n be? Because a sub n, we already know that. That's our original. So that's sine of 1 over n. You can let b sub n be anything you want. I'm going to let it be 1 over n because I know it's going to be in the denominator. And since it's going to be in the denominator, we can make this clever substitution and change the limits in the way that we used to with some previous things. So that's what I'm going to do. Limit as n approaches infinity of sine of 1 over n over 1 over n. Now we can notice that we have the same term here, 1 over n, and we have the same term embedded there in the numerator. So we can replace this with the same variable, t and t. And we know both of these are going to 0. They're both going to 0 because when we plugged infinity into that denominator, that was going to 0 because it's 1 over infinity, which is 0. So these t's are going to 0. Now that we know that the t's are going to 0, what happens if we plug in 0 into sine? You would get 0. You plug in 0 into t, you get 0. You get 0 over 0, which means, just like when you get infinity over infinity, you can use L'Hopital's rule. L'Hopital's rule says that you can take the derivative of the numerator and the derivative of the denominator. So the derivative there would be cosine of t. We're taking the limit as t goes to 0, and the derivative of that would be 1. So we would just have cosine of t. What happens when we plug in 0? Cosine of 0 is 1. So this equals 1, which means that it's not 0 and it's not infinity, just as we wanted. So this is going to exhibit the same behavior as 1 over n. So does 1 over n converge or diverge? It diverges because it's a harmonic series. It's something you should probably just remember. But if you don't remember, then remember that it's a p series. It's a p series. And with a p series, maybe it's even harder to remember. But if you're less than or equal, if p is less than or equal to 1, then it's going to diverge. If it's greater than 1, then it's going to converge. So this definitely diverges, and therefore this diverges.